Hello, everyone. Glad to be here at SREday, and thanks for joining me. And surprisingly enough, the topic of my talk will also be about platform engineering. But unlike maybe the previous talk, this one will be a bit more basic. So if you're more new to the topic, I think this could maybe complete some of the missing boxes that you might have seen. And just to get to know the audience, with a show of hands, it worked for the keynote this morning. How many have platform engineering in their organization? Raise your hands. Very good. Leave the hands up. Leave the hands up. You know the drill from this morning. Now, how many of you work in an organization of 100 people or more? Okay. How many? 500 people or more? 1,000 people? 5,000? 10,000? Okay. Remember what you saw around you. That'd be very relevant. Thank you very much. Platform engineering. Yeah, it's very hyped. Enough to look at the agenda for this conference. But today I'd like to, talk about this hype. And as you can see, Gartner just recently released its yearly hype cycles. This is the hype cycle for SRE, Site Reliability Engineering. We're here at SREday. And surprisingly enough, platform engineering is high up there at the peak of inflated expectations. Yeah, not more hype than that you can get. And this is for the SRE cycle, hype cycle, but platform engineering as well in the containers hype cycle and others. So definitely starring all the hype cycles. And actually, when I was asked for my predictions for this year, for 2024, back in the end of 2023, I actually predicted that this year will be the year that platform engineering will move beyond the hype cycle and into production-ready, production-grade levels. Yet to be seen. It's written, so you can test me out at the end of the year. But definitely, I want to talk and look into platform engineering beyond the hype. And this is the topic of today's talk. So my name is Horovits. That's me less than 48 hours ago. I was in Vienna. I was at Open Source Summit Europe. That's the flagship event of the Linux Foundation, for those who don't know. I was there talking about open source observability. That's not the topic of today, but if you are interested in open source observability, more than happy to talk about it after the talk. It's my favorite topic. I also have a podcast called Open Observability Talks, exactly about that. So if you're into the topic, check it out on YouTube or wherever you get your podcasts. About me, I'm a DevOps specialist and a developer advocate. I've been around the DevOps space for many years, working with vendors, with open source projects, with the community. Actually, technically now I'm between jobs, so if you have anything interesting, also grab me after the talk. And I'm also a CNCF ambassador. So CNCF is in the Cloud Native Computing Foundation. For those who don't know, where you find Kubernetes and Prometheus and OpenTelemetry, Argo, Flux, and many other popular open source projects. So if you do have any questions about the cloud native stack, also grab me after the talk. Happy to talk about that. And as you can see, you can find me everywhere at Horovits. My surname is my handle everywhere. So if you want to catch up afterwards, DM me, or if you tweet or toot anything out of this talk. And as my t-shirt shows, I'm also a platformer, which is exactly why I'm here to talk to you about this topic today. And with that, I'd like to talk, maybe before we talk about platform engineering, let's talk about the challenges of SRE and DevOps that actually we come to solve with platforms. And particularly when it comes to DevOps at scale. So the first problem is the organization grows and you start having multiple product lines, multiple business units, lines of business, and so on. You start seeing this pattern of toil and waste, where individual product teams solve the same problem again and again, independently and in no correlation to other teams. Oftentimes, they're not even aware that the team next door solved the same problem. And even if they do, the other team solved it so tightly coupled with their own implementation and their own product that it's a pain, and it's actually simpler for this team to just reinvent the wheel for their own needs. So that's the first problem that we see very often. The second problem, as you can see here, is the cognitive load. Okay, the cognitive load comes from the shift left. Everyone praises shift left, but let's be honest, shift left comes with a baggage. And that is that engineers are today, developers, are expected to know a lot about their infrastructure. So the common engineer suddenly need to know the developer about Kubernetes, about Docker, about Terraform, about Postgres admin and Jenkins admin and whatnot. And all of that is cognitive load, and it's also the focus from actually focusing on the core business logic that they're there to do, on the application and the things that bring value to the company and the role of this application team. And the third pain that I see very often is the pain of fragmentation and inconsistency. That engineers come and they find multiple ways of doing things, and there's no right way of doing things. There's no recommended way. There are no golden paths. Very confusing. And also, developers find themselves very difficult, or the organization finds it very difficult to consolidate and create this compliance, security-related enforcement throughout the organization. So that's what we come to solve. Don't reinvent when you can reuse and adapt. That's the premise that led to platform engineering. Okay? Don't reinvent when you can reuse and adapt. Now we understand why. I hope that by now you understand why platform engineering is needed. Now let's understand what it is. To be honest, I haven't found yet a good definition of platform engineering to take out of the box. There are lots of them and very confusing. So I brought my own, but actually I broke it down into the main takeaways that I want you to take about what platform engineering is. So as you can see, my take on it, platform engineering is a DevOps approach in which organizations develop a shared platform to improve the developer experience and productivity across the organization by providing self-service capabilities with automated infrastructure operations. Now, again, let's focus on what the real takeaways the central takeaways are out of this definition. So first of all, platform engineering is a DevOps approach. Okay, it's not a whole new beast. It's simply a DevOps approach. Secondly, it comes to improve, first and foremost, the developer experience and the developer productivity. And lastly, the way that it does that is using shared services provided across the organization for a self-service consumption by the wider product teams. So this is a definition and it's very abstract. So let's take one example to make it very concrete and simple for all of you. And I chose the example taken from Citrix. I had the privilege of hosting the director of platform at Citrix at the time on my show on Open Observability Talks. You have the QR code here for those who can't see. I'll move here. And it was a fascinating 1-hour episode about really the ins and outs of how they implemented platforms. But I like this story because it's really representative of the process that you go through. It starts by identifying the problem. In that case, different teams investing a significant effort in creating certificate rotation. Again and again by different teams throughout the organization. Secondly, and very important, you don't go as soon as you identify that and jump straight to implementing. You first try and quantify the benefit, okay? In that case, the platform team sat down with the product teams and then quantified it and realized that they can actually reduce it from 300 story points to 50 story points that it would take to integrate a self-service that will be provided to the teams. And once they quantified it and got the buy-in with the first teams, then they went ahead and delivered the self-service certificate rotation for consumption to all teams across the organization. And that really is the recommended flow for introducing that. Now, we've already seen from the definition I gave you before that essentially platform engineering is a DevOps approach. Not a whole different beast that I understood, but still, what's the relation between DevOps and platform engineering? That's a question that I get asked very frequently. So in the next slides, I'm trying to give my way of explaining it simply. So let's start with DevOps and SRE. We all know that DevOps uses tools to streamline deployment, management, and monitoring using automation and visualization. Okay, that we know. And platform engineering, okay, takes these tools and best practices and productizes them as reusable services and tools for use across the different engineering teams and across the use cases in the organization. Okay? And remember, productizes them. That's the operative word. And remember that, we'll get back to that later. Another way that I use to explain the relation between platform engineering and DevOps is the classic DevOps maturity model. The typical maturity model, as you can see here, goes from initial to managed, defined, measured, and then up to optimized. Now, when you're in the earlier stages, when you're in manage and define, you'll see that typically each team creates its own DevOps practices to fit its needs, and then the collaterals, the deliverables out of these are typically blueprints, such as Terraform modules, Docker images, and so on. And then what we see, the pattern we see is that engineers clone and then adapt it to their own needs and then use that. The problem is that as soon as they clone it, then it detaches from the source and it becomes its own island, its own silo, and it's also localized within individual teams. So there's little correlation to other parts of the organization. Then as the organization matures and scales and moves into the measured and optimized phases, the organization starts collecting data and understanding the impact of DevOps on the organization. And then this measurement exposes these pockets of inefficiency throughout the organization. Remember, the same work being done again and again, and then the need for consolidations become apparent, and therefore the need for platforms becomes very evident. So this is where platforms become material in the maturity lifecycle. And again, taking a very concrete example to make it less abstract, I took the example in this case of Spotify. Spotify built their own developer platforms, and essentially, actually, they later open sourced that as Backstage, for those who know it. I'll say a word about that soon. It's now a CNCF project. But let's look at what they shared. And as you can see, a very impressive result. They talk about 2.3 times more active in GitHub, create twice the code changes in 17% less cycle time, deploying software twice as often, and the software is deployed for 3 times as long. And last but not least, the cognitive load, remember that, bears also cost in terms of employee churn. You can see here 5% more likely to be at Spotify 1 year later. So I think this example showcases exactly these benefits that we talked about before. Now, I talked in the definition and a few times afterwards, I mentioned again and again shared services, and that rings a bell from PaaS, Platform as a Service. I don't know how many of you remember from about a decade ago, PaaS, who remembers this term? Okay, a few of them. So back in the day, we neatly organized the world into 3 layers: IaaS, Infrastructure as a Service, Platform as a Service, and Software as a Service, the IT cloud era. And then we had things such as Heroku and AWS Beanstalk and Google App Engine and Cloud Foundry that were the hot thing back in the day. Who uses these today? In the show of hands? Okay, we have 2 hands there at the back, which I guess comes to show you that it really didn't stick. And the question is, then people ask me, okay, this didn't work. Is that PaaS, Platform as a Service, all over again? And my answer is that no. I think that no, and I've lived through that. I even worked at a startup called Cloudify that later was acquired by Dell EMC that was squarely about this domain, PaaS. So I lived through that, and I can tell you that no, and I want to look at why no, and actually what are the main differences that make platform engineering different. First of all, PaaS was very opinionated, sometimes maybe said too opinionated. Organizations, it was very nice when you can work strictly according to what Heroku offered. It was very nice. You took building blocks, you took one messaging queue, one messaging bus, one database, and hooked them up. And it was very elegant, very abstract. But what if it didn't work exactly for what you needed? And that was 10 years ago. Today, the IT realm is far more complex than that. And the difference between MongoDB and Cassandra is a hot debate. And that's just document databases, not to mention graph databases and this and that. So this simply is too opinionated. Secondly, there's a vendor lock-in. Okay, so if I wired my entire thing according to, let's say, for example, Heroku, what happens if I want to move? Now I'm locked into that. And thirdly, okay, so let's say I want to move, but I already have everything is already in Terraform. How do I move to that? Which was not easy to say. So the conclusion is, and I have a whole lecture just about that, but putting it aside, we don't need platform as a service. We need platform as a product. Okay, platform as a product. And how is it different? Okay, so first of all, and we heard that also in the previous talk, it's developed by in-house platform engineers sitting side by side with your product engineers. So they can make sure that it suits the organizational conventions, tooling preferences, development and deployment styles, compliance requirements, and so on and so forth. And also, that's one thing. And the second, it's optional and composable. Okay, optional and composable, meaning that you don't have to buy into the entire suite, the entire Heroku thing. You can actually take the pieces that suit you and use them without maybe using other pieces. Okay, optional and composable. Treating your platform as a product starts with treating your engineers as your users. That's very key. And when I talk about treating your platform as a product, what does that really mean? So first of all, user research, okay? Treat your product engineers as your users, just like any other product. Understand their problems, understand their needs, and elicit the requirements from that in very close contact and in iterative manner so that you can improve based on the feedback and so on. Secondly, it should be data-driven, just like any product management. Quantify the value and measure the success, and balance simplicity with flexibility. We engineers have the split brain that we like to have everything exposed to us on the one hand, and on the other hand, we want to abstract everything. So make it simple for me. I don't want to know anything about that. But then if I know this flag from Docker and I don't have it here, what the heck are you taking this ability away from me? So this split brain is something that you need to manage to strike the right level of abstraction. A note, we saw a bit about the CNCF working group, the platform working group within the CNCF, the Cloud Native Computing Foundation, that issued the maturity model for platforms. There's another now research ongoing about platform as a product. And actually, we're looking for people to interview that are involved in platforms in any shape or form, to interview them and to collect the data to issue a new white paper about platform as a product. If you are interested, reach out to me after the talk. Happy to tell you more about that and get you involved in this initiative. So that's in a nutshell. And another very important point, in addition to the needs arising from the various individual developers in the product team, platform engineering teams also need to cater for organization-wide cross-cutting concerns. And I gave a few examples here. First of all, the security and compliance. Before we said, when each team implements its own thing again and again, one of the impacts of that is that it's very difficult to enforce security and compliance. Now, this is one of the benefits of platform engineering. And then we can essentially, in terms of the compliance, we can make sure that there's a compliance with relevant regulations across the organization. We can establish consistent convention and golden paths throughout the organization through that. And we can also address cost efficiency, FinOps related, because if each team now chooses its own tool, you may be in a massive 10,000 employee organization, but then it's just a team of 30 that uses that tool. However, if we have one consolidated platform engineering that addresses it with a vendor, they can negotiate better deals. They can optimize even internally the resource utilization that may be shared across different platform product teams and so on. FinOps, very good benefit that you can get out of platform engineering and reducing the overhead. These are some of the cross-cutting concerns. Another thing that I want to be looking for from the CNCF is the view of the capabilities of the platform. This is taken from the first white paper that was issued. You have the QR code here for the white paper that maps the platform. Looking at it bottom up, you can see obviously we have the infrastructure providers that you use. I don't know, Amazon, Google, whatnot, OpenShift, whatever you use. And then looking up, we go into the platform capabilities. It could be environment and resource capabilities like runtime environment and Kubernetes infrastructure that is mentioned here a lot, and databases and so on. And then there's software release pipeline, builds, CI/CD, and so on. It could even be environment stuff like the developer environment itself, like managing the repos and registries. Think about your Docker hub and things like that to be managed centrally by the platform team. SBOM management, security, software bill of material, and so on. It could be security related, identity, RBAC. I talked about certificate rotation, AAA, whatnot. There's observability. As I mentioned, I come from the observability space, so think about everything observability, like the code instrumentation, the data enrichment and metadata, local daemons, collectors, sampling, aggregations, rollups, indexing, whatever. All of that being taken care of, or at least the fundamentals provided centrally to the organization. In some places, they even go beyond into business-related reusable services like billing, metering, and so on. So it can even get there depending on your organization. And then on top of that, you have the platform interfaces, web portals, self-service APIs, golden path templates, and docs. All of that is essentially platforms. And again, check out the white paper for more information by the CNCF's platforms group. Now, I mentioned before Backstage, an open source that was originally created at Spotify and then released and contributed to the CNCF. Now it's an incubating project under the CNCF. You see very impressive stats there in front of you. I had the privilege of hosting the director of engineering back in the day. Today he's no longer at Spotify, but he was the one developing this. You have the QR code here for the fascinating episode about why they developed the platform internally, how they develop it internally, and even their journey into open sourcing it and contributing into the CNCF and building the community around that. A fascinating journey, interesting read. And just to wrap up with a summary, don't reinvent when you can reuse and adapt. Remember that rule of thumb. This is the driver for platforms. Platforms, as I mentioned, first and foremost come to improve the developer experience and the developer productivity by removing toil and cognitive load. Platforms promote organization-wide consistency, security, cost efficiency, and as your organization grows and matures, it becomes a necessity. We talked about the developer DevOps maturity lifecycle. Not everyone needs platforms in the organization. Only when it comes to the scale where it materializes, you'll actually see the drivers that we talked about before. And remember, treat your platform as a product. For more about that, I wrote this article about platform engineering. You have the QR code here, and it has a lot more information about this topic and a lot more references about end use cases. Check it out. I hope it helps you. And with the music, I'm Dotan Horovits, and thank you very much for listening.
Questions?
Thank you, my friend, for saving me. And great seeing you again.
How do you think people should draw a line between, reusing and adapting versus, this is too many opinions? Like, at what point is an opinion not reusing and you're locked into it? How do you sort through those things? For example, I would imagine the way you implement several security things is you probably shouldn't have your own opinion of that, right? Like, you should reuse what's available out there instead of customizing it to your own use, or I don't know, something like that.
That's true. So I think it's a great question. And I think the line strikes when it's really the core of your the business drivers that your team is in charge of. So if it's boilerplate stuff, your team is about creating the best e-commerce experience in the logging and you're messing with certificate rotation, that's not where your focus should lie. So if it's something that feels like you're wasting your time, and the developers will tell you, we shouldn't be focused there, we should be focused there. So if it's this sort of things that are toil and waste and headache for the engineers, that probably is something that if you have something out of the box, use that. If not, maybe you should proactively go to the platform team to solve that problem for you. Take it off your head. That's the rule of thumb that I would say about that.
Thanks.
Sure. We have a question over here.
Everyone, all right. Do you have any advice on avoiding platform engineering teams or whatever organization structure we have for it from becoming silos in their own right?
The best advice that I can say is what I said when I talked about the nature of the difference from PaaS and platform as a platform engineering, which is that they should be sitting side by side. The fact that they're in the same organization should be the key here. The fact that they sit down, they treat them as users, they ask them what they need, they involve them in the definition of the product features. Essentially, just like product managers, they are your users, define the platform, shape the platform with them, and then they actually become part of what the platform provides. That's the way not to become a silo. So make sure that the fact that you're part of the organization is not technical and only on paper, but actually becomes the modus operandi of the team.